Good morning, class. Today we're going to talk about the method of contrast, which is how we compare groups of groups to one another. And what I mean by that is, let's review our working example this week of our smoking exposure groups and lung function. Okay, and so we have 6 groups, as you recall. We have, at one extreme, we have the heavy smokers with a very low lung function of 2.59 on average, and at the other extreme we have our never smokers with the highest lung function of 3.78, and in between we have light smokers, moderate smokers, those who smoke but never inhale, and passive smokers, who are people who are exposed to smoke in the workplace but do not smoke themselves. Okay, and we've seen that there are differences between these groups, and we have also seen that it makes some sense to group the groups into a smaller set of groups that we might call, for example, heavy exposure, light exposure, and no exposure. For example, we could do that. And one reason to do that is because it simplifies the presentation, and depending on the audience you're speaking to, that can be beneficial. If you're talking to a newspaper reporter and it's easier to talk in terms of 3 groups rather than 6 groups, that may be an incentive to do that. So, one method of doing that is called the method of contrasts. And the first thing I need to do to implement this method is convert our groups into factors. They were just characters before. And if we look at the levels of our factors that I just created, we can see that they're actually not in, okay, well, I guess the table also gave the same order. The order is not the logical order that going from high to low or low to high. It's a fairly random order, and so we have to pay attention to that when we're writing our contrast statements. Okay, so the way the contrast operation works, it's a bit tricky, but we want to classify our data into groups such that the members of one group have the same value and the members of the other group have a different value, and the sum of all the values add up to 0. So for example, if we want to compare non-smokers to everybody else, okay, so that's a possible grouping you want to do. You want to compare those who have no exposure to smoke with those who have some exposure to smoke. Okay, so this is a common, so this is none versus some. And to do that, since there's 5 members of one group and 1 member of the other group, we assign a value of 1 for 5 of the members and a value of -5 for the other member, and the sum of all these adds to 0. I could have reversed it. I could have done -1 and +5. I could have also done all 2's and -10. It doesn't matter as long as the sum sums to 0. Okay, and then we run a contrasts function, and we don't really need to say x equals because that's really the only term in this function. Okay, so the format of this function is contrasts, parentheses, and then the variable that we want to run contrast for, and we want to assign that the contrast variable that we just created, which was contrast1. Now, could I have done this and gone directly? Yes, I could have. I could have said contrast function and then actually put the contrasts and save that intermediate line of code, but I'm following how the textbook presented this information. Okay, if we look at the structure of our new I didn't run line 13, excuse me. If we look at the structure of our variable, okay, so we're looking at the structure of our group variable. We see that it's a factor with these 6 levels, and now we have the attribute of contrast, so we know that we have successfully assigned the contrast to this variable. Okay, and then we run the AOV function, which we've seen before, analysis of variance, and we're interested in the lung function as it relates to group using the tilde and using the data FEF study. Okay, so this is exactly the same as we've done in the past. So I'm running the analysis of variance, assigning that to a variable called AOV result. And then here's the new twist, line 16. I'm creating a new variable called AOV result underscore contrast, and we have a new function which is the summary.aov. Okay, and so I'm applying the summary.aov function to my AOV result from line 15, and then we have this split parameter where I'm going to split into a list. The syntax here is a bit convoluted, and I'm grouping my results into another list, which I'm calling exposed versus non-exposed, and I'm assigning that a value of 1. Okay, so the syntax in line 16 is definitely convoluted. If I were building this function from scratch, I would endeavor to make this a bit more tidy looking, but it's the only way I know how to do this. So the goal here is to compare the groups that were exposed, 5 of them, with the group that was unexposed, 1 of the groups. All right, and if we run line 16 and then we look at what is in the variable that we just created, AOV result underscore contrast, we see what we're interested in is this second line. The exposed versus unexposed group has a p-value, and that's what this is saying, the probability of a f value that is greater than what would be expected by chance. So that is a fancy way of stating p-value. The p-value is less than 2 times 10 to the negative 16th, which is the smallest number that R computes. And so this tells us that there's a significant difference between the exposed and the unexposed. Now we would expect this because we already know that there's a significant difference between unexposed and every other individual group. So the group of groups, we would not expect anything different, and in fact we don't see anything different. Okay, so this would be one way that you could present your results in a simpler fashion if you wanted to. In lines 18 through 22, I create a second way of doing this, which is active, what I called active versus passive exposure. And for active, I've put in heavy smokers and moderate smokers. For passive, I've put in light smokers, passive smokers, and never inhaled. And this time I'm excluding non-smokers. I'm excluding the group that had no exposure at all. So here I'm comparing 2 groups, both of which were exposed, and I'm excluding one group entirely. All right, and if I run lines 18 through 22, and I look at the result of that, we see active versus passive. The p-value is less than 2 times 10 to the minus 16th. So this is telling us that there is a very big difference between heavy and moderate smokers, and other ways people get smoke. Perhaps passive is not the best word here. Perhaps I could have called this heavy versus light exposure. That might have been a better way to state this. Okay, so in my third example, I just wanted to contrive a way to show you an example that does not show a difference. And this is very contrived because you would never, this makes no sense, but I'm comparing the extreme groups to the middle group. So in one group I'm placing the heavy smokers and the non-smokers. And in the other group I'm putting everybody else. So I have 4 groups with a -1. Actually, it should be 4 groups with a -1 and 2 groups with a +2. Okay. So that it adds to 0. And I run lines 25 through 29. And I got an error. Let's see. Why did I get an error? Contrast apply only to factors. Oh, sorry. I got a typo here. That should say group. That should say group. Okay. Wrong variable name. Okay, so line 26 should be exactly the same as line 19. And line 28 should be exactly the same as line 21. Okay, very good. Okay, I run this group of lines again. I got another word levels here. Alright, let's try a third time. Lines 25 through 29. Okay, that time it worked. Okay, and then we look at our AOV result underscore contrasts. Okay, this time, extreme versus middle, the p-value is 0.11. So there is no significant difference between the groups at either extreme and the groups in the middle, which makes sense because there's no logical reason that would be true. And so indeed it is not true. So you might have thought at this point that it makes sense to simply, why couldn't you have simply just recreated your groups in the data itself? So instead of your 6 groups, you could have written a statement grouping the groups together into these other words: exposed, unexposed, heavy, light, etc. And yes, that is definitely an approach that you could have taken. This is an alternative approach. This way, I think, can be more helpful when you have large numbers of groups. And so here's an example from my own work. In a study that is trying to compare different kinds of chemotherapy regimens on outcomes, on survival for cancer. And so there are something like 20 different chemotherapy regimens for Hodgkin's lymphoma, for example. And 20 different chemotherapy regimens is too many to present in a publication, right? So we want to group together, to some extent, chemotherapy regimens that are similar to one another, that are logically similar, to simplify our presentation and also to gain statistical power, because when you have lots of groups, some of the groups may only have a few samples in those groups, right? Some of the chemotherapy regimens are not very common, so the numbers are small. And so we are trying to collapse those 20 chemotherapy regimens into something more like maybe 6 or 7 or 8, and we are using this type of logic to help us do that. And so it does have some real-world relevance. This is not part of, well, there's no direct homework question on this technique, but I think it still is useful and helps you get a handle on how the analysis of variance works more generally. Thank you for your attention.